Thread: Google's new quantum computing just put a countdown on every blockchain. Crypto is at an existential threat. If you hold Bitcoin BTC or Ethereum ETH, you'll want to read this. Only a few blockchains are built for the post-quantum era. What's going on? Tech giant Google and other players are pushing quantum computing into supercharged territory, computing power that's orders of magnitude faster than today's supercomputers. Quantum computers are no longer sci-fi. That spells a looming question. What happens when this power meets blockchain security? To per how are blockchains secured today, most of the leading networks rely on a hashing algorithm, for example, SHA-256, that secures block data, and mining processes, for example, in Bitcoin. A digital signature algorithm, notably the elliptic curve digital signature algorithm, ECDSA, which secures wallet transactions across many networks. If the matrices underpinning these algorithms become breakable, the whole foundation is at risk. 3. Enter Schur's algorithm, the quantum wildcard. Schur's algorithm is a quantum algorithm that can factor large integers / solve discrete log problems exponentially faster than classical computers. In short, it's capable of dismantling ECDSA and similar schemes if a sufficiently large quantum computer exists. In blockchain terms, your public key exposed once you make a transaction could become a vulnerability. Quantum computers threaten current encryption methods like ECC and RSA. For why this matters for BTC ETH holders. Take Bitcoin. Once you send funds from a wallet, your public key is revealed on-chain. A quantum computer in possession of that public key might derive the private key. That means funds sitting in used addresses are exposed. Analysts estimate millions of BTC billions of dollars could be in wallets whose public keys are already exposed. It's not just theory, many are tagging this as a ticking clock. 5. Who's ready for the post-quantum era? Because SHA-256, ECDSA, and many classical schemes will eventually become vulnerable, the industry is turning attention to post-quantum cryptography (PQC) algorithms designed to resist quantum attacks. One widely noted algorithm, EDTA 5519, though note, EDTA 5519 is still classical elliptic curve based and not inherently quantum proof. The critical thing, blockchains that build in agility and quantum safe upgrades will be in stronger shape. 6. Some networks are taking action. For example, the Algorand Algo blockchain has publicly documented its path to post-quantum readiness, including the adoption of the lattice-based signature scheme Falcon. The takeaway being quantum ready means more than a claim. It involves implementing PQC, ensuring history is protected, and maintaining protocol upgradability. 7. Why BTC ETH aren't exactly nimble. Networks like Bitcoin and Ethereum face big hurdles to becoming quantum secure. A major protocol upgrade, hard or soft fork, would be required. Consensus across a sprawling developer community is needed. Users' wallets must migrate to quantum-safe keys. In short, the inertia is large, and the window to act is finite. 8. A ticking clock estimated timeline. While quantum computers powerful enough to break mainstream cryptography are not yet here, multiple sources estimate we may reach practical risk in 5 to 15 years, some institutions preparing for transition by 2035. The key risk: adversaries might engage in harvest now, decrypt later, attacks capturing encrypted data today to crack later when quantum tools mature. 9. What the future of crypto looks like. If quantum computing becomes practical, we're looking at a major reset, not just regulatory, but cryptographic. Traditional assumptions about security could collapse. Financial infrastructures, central banks, clearing systems are already examining quantum-safe transitions. Networks that adapt quantum-proof or ready for upgrade will hold competitive advantage. Others may struggle. 10. Who wins this race? Survivors will have these traits. Crypto networks built with agility and quantum-resistant cryptography in mind. Systems with flexible upgrade paths and an infrastructure that acknowledges the quantum threat. Early movers who migrate keys, protocols, and wallets ahead of the threat becoming urgent. 11. What you can do if you hold crypto. Assess exposure. Wallets that have revealed public keys, i.e., spent funds, are more vulnerable in a quantum scenario. Follow developments in quantum-resistant cryptography and watch networks that incorporate PQC. Recognize that this is a long-term risk, not necessarily an immediate hack tomorrow, but preparation now matters. 12. Final word. Quantum computing won't simply be a tech novelty, it could challenge the very foundation of digital trust. If you're invested in blockchain, the next risk horizon isn't just regulation or macroeconomics, it's physics. Adaptation will matter.